In this video, we will talk about when doing conditional probability questions, when should we use the conditional probability formula versus using a tree diagram to evaluate it. Okay, so I want to talk about those two categories. So the conditional probability formula, when is this better versus tree diagrams, and when are those better? Okay, so as we saw in our last video with the example we did, if both work, and by both I mean the formula as well as tree diagrams, the formula, let's give ourselves more room, the formula is often quicker. And we saw this in the previous video. Okay, and another situation where using conditional probability formula would be better is when drawing a tree diagram is challenging. Then the formula, using the conditional probability formula, straight up is better. With tree diagrams, on the other hand, this comes with a little bit of practice and experience in part, but one of the ways to know is if we use, or if we don't have enough info in the conditional probability formula, then tree diagrams are typically better because they'll help us uncover that information. Alrighty, so that said, let's look at an example. And we'll think about these two methods and which one might be better. So the example says that a group of 10 students consists of 6 freshmen and 4 sophomores. A group of 4 students is selected at random. If the group has at least 1 sophomore, what is the probability that there are exactly 3 sophomores? So let's start off by writing what it is that we want to find. And we want to find a probability. The probability that there are exactly 3 sophomores, but we're given that the group has at least 1 sophomore. So we want the probability of getting 3. I'll write 3 sophomores, given that there's at least 1 sophomore. So I'll write that with a greater than or equal to sign, greater than or equal to 1 sophomore. So let's think about this with a tree diagram first. With a tree diagram, sorry. And I'll put a question mark because maybe at this point we're not sure if a tree diagram is going to be the best approach to this. Okay, so let's write where we would begin the diagram. And because we're selecting a group of 4 students, we could definitely think of this in terms of stages and pick the first student, and then pick a second student, pick a third student, pick a 4th one, and then we'd form the outcomes and then write down the probability. Whoops, let's write that better. Probability of each outcome. So from where we begin, we could pick a freshman, I'll call that F, or we could pick a sophomore, which I'll call S. And then after that, from each of those, we have 2 branches, because we could pick a freshman or a sophomore. And same thing from the S, we could pick a freshman or a sophomore. And we're going to keep going like this. So we'll create 2 branches from each of these, either freshman or sophomore. Same thing here, freshman or sophomore. 2 branches from each of these, and we'd have more branches as we get to the 4th step. The only thing that we might have to be careful about if we went about it like this is, are there enough freshmen and sophomores for all of these outcomes, all these branches that we'd have? And in this case, I can tell there would be, because we're just picking a group of 4 students. So we could definitely fill that with all freshmen if we wanted to, because there's 6 of them. And we could fill it with all sophomores if we wanted to, because there's 4 sophomores. If we had a scenario where there were only 3 sophomores, then we'd have to get careful towards the end in the 4th step and make sure I didn't put just 4 of these sophomores if I only had 3 of them, because that would be impossible. Alrighty, but here we don't have to worry about that. So I'm just going to put a dot, 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 and notice, well, there are a lot of branches here. So that means this is definitely looking tedious. Tedious to even draw, and then I'd have to put probabilities on each of these and write the outcomes and all those probabilities. Seems like it'll be tedious and a bit of work to do, so I'll put a sad face. So let's try the conditional probability formula. All right, so I'm starting up at the top of the next page to give myself more room. So remember, the problem said that there are 4 sophomores and 6 freshmen, and I'm trying to find the probability that we have exactly 3 sophomores in our group of 4, given that there is greater than or equal to 1 sophomore, or at least 1 sophomore. So let's use our formula for conditional probability, and we have equally likely outcomes here, because each of these people, the freshmen and the sophomores, are equally likely to be selected. So I'm going to, instead of putting probabilities on the top and the bottom, I'm going to write the number of elements in each set. So on the top, it's going to be the number of elements, the number of ways I could have 3 sophomores intersected with having greater than or equal to 1 sophomore, the intersection of those 2 events. And on the bottom, I got to count the number of ways I could have greater than or equal to 1 sophomore. Okay, so let's think about this event on the top. So this is saying that I need to have 3 sophomores. Intersection means and, so 3 sophomores and at least 1 sophomore. Well, that sounds a little bit redundant. It would be just easier to say that this is the same thing as needing 3 sophomores. Because if I have 3 sophomores, I definitely have at least 1. So that's a more concise way to write this event. Okay, so this equals the number of ways to have 3 sophomores in the group on top. And on the bottom, the number of ways my group could have greater than or equal to 1 sophomore. So now let's think about the numerator first. So we will find the number of ways we could have exactly 3 sophomores in our group. And then we'll come back to the denominator. So for 3 sophomores in the group, that would mean, well, there's 3 sophomores. And the group has to have 4 people, which means there needs to be 1 freshman as well. Okay, so for picking the sophomores, the order in which I pick them doesn't matter. So I know I'm going to use a combination. So how many ways are there to choose? We got to pick 3 sophomores. So choose 3 out of, and there's 4 sophomores total out of 4 sophomores. So we would write that as 4 choose 3. Okay, and so let me put a bullet point next to this and a bullet point next to, now I got to pick 1 freshman out of the 6 freshmen that I have, and this is easier. There's just 6 ways. 6 ways to choose 1 out of the 6 freshmen. If I wanted to with a 6, I could have written this as a combination. I could have done 6 choose 1, but I think it's easier to just write it as 6 because I'm just picking 1 person, so it's easy to write down that value. Okay, so we are ready to write down the number of ways our group could have 3 sophomores, because I just take the 4 choose 3 and I multiply it by the 6. And if we work this out, we end up getting 4 times 6, which is 24. So I'm going to highlight this in blue as well. 24 for the numerator. All right, so now let's do the denominator. Let's count the number of ways we could have at least one sophomore. So we want to find the number of ways to have greater than or equal to one sophomore in our group. And at this point, we've counted things like this a lot. So hopefully we're starting to get better at recognizing, well, what's the technique that's going to be helpful here? And it is going to be to use complements. If I don't use complements, I got to consider a bunch of cases, like what if there's one sophomore in the group, two sophomores in the group, three sophomores, and four sophomores. It's going to be easier to use the complement. So we want the number of ways to have at least one sophomore. So if I use complements, this is equal to the number of total groups that we could form minus the number of things in the complement of this set. So this set says I have at least one sophomore. The complement of that would be, well, groups with no sophomores. That would be the complement. Okay, so I'm going to highlight this because this is the denominator quantity. We've been highlighting it green. Let's figure out the ways for both of these quantities on the right-hand side. So when I find the number of total possible groups, the order in which I pick the four people doesn't matter. So I'm going to use a combination. So let's think about how many people I'm choosing, and from a group of how many. We need to choose 4 people for our group out of, and there's no restrictions here because I'm counting the total number of groups. So there's 4 people that we're choosing out of, there are 10 total people, remember. 10 total people. How many were there of each? Well, there were 4 sophomores and 6 freshmen. So 10 total people. Okay, so we are going to have 10 choose 4 here. And then minus, now I got to count groups with no sophomores. And again, order doesn't matter when I pick those people. So I'm going to use a combination. So we have to here choose purely from the freshmen. And still, I got to form a group of 4. So I'm going to choose 4 of them. 4 out of, and how many freshmen were there? Let's see, there were 6 freshmen. So here I would write 6, choose 4. Okay, so the number of groups with greater than or equal to 1 sophomore is going to be equal to 10 choose 4 minus 6 choose 4. And if we work out what that is 195. So let's highlight this whole thing. So that's going to be the denominator of our probability fraction. So we are now ready to write it out. The probability, thus, the probability of having exactly 3 sophomores in our group. The numerator, let's see, was 24. The denominator is 195. We've been highlighting the denominator is green and the numerator is blue. And I could simplify this fraction by dividing the top and the bottom by 3. And if I do that, I'll end up with 8 on the top. And on the bottom, I'll get 65. So 8 over 65 is our probability. So in terms of our goals for this section, we finished our second goal, recognizing when we use tree diagrams versus when we use conditional probability formula to evaluate conditional probabilities. But this is something that genuinely takes practice to get more comfortable with. Don't be worried if you try one method, you go down a path and you get stuck, and then you got to try the other one, and then it works out after some effort. That is absolutely normal, especially in the early going with these questions.